Welcome to the world of operation technology OT security. In this captivating presentation, we will explore how to protect a power plant, one of the most critical infrastructure in the city, from both cyber and physical attacks. Imagine yourselves as the manager of this power plant, where advanced systems and physical devices collaborate to produce and supply essential electrical energy to the entire community. Operation and technology is like an intricate balance between physical devices and digital systems that manage industrial operations. In our power plant, we use automated controllers to monitor and regulate energy production. For example, monitoring device constantly control the load and operating the condition of turbines to ensure optimal efficiency. However, the increasing connectivity through the industrial Internet of Things has introduced new challenges. For instance, imagine a cyber attack compromising the power plant control systems. Hackers could manipulate the electricity generation parameters, causing interruption in power supply or even physical damage to the facilities. To better understand OT security, let's differentiate it from information technology security. In IT security, we focus on protecting sensitive data such as personnel and financial information. For example, securing customer data in a bank from unauthorized access. On the other hand, in OT security, our main objective is to protect critical physical devices such as generators, transformers, and control systems. Picture the power plant as a fortress where OT security acts as our protective shield to maintain safe and reliable operation. On the world operation technology, industrial network and critical infrastructure face various unique threats. Some examples of threats include ransomware, malware that holds critical system hostage by blocking access or encrypting data, demanding ransom to unlock them. For instance, a ransomware attack on a power plant that locks the control system, halting electricity generation until ransomware is paid. DDoS attacks, distributed denial of service attacks, overload system with an excessive flow of requests, causing slowdowns of or halting operations. For example, a DDoS attack on a transportation company causing service delays and disruption in monitoring systems. Industrial espionage attacks, cyber spies attempting to infiltrate OT systems to steal sensitive information or gain unauthorized access. For example, an industrial espionage attack on a factory attempting to steal trade secrets or production formulas. To create a robust OT security strategy, several key principles are essential. Risk assessment. Understand and evaluate the specific risk in industrial operation and infrastructure. For example, identify vulnerability in industrial control system and assess the potential impact of an attack. Network segmentation. Separate networks into isolated subnets, reducing the propagation of potential attacks and limiting unauthorized access to critical parts of the infrastructure. For example, create a separate network for industrial control, keeping administrative and production systems separate. Continuous monitoring. Implement monitoring system to promptly detect suspicious activities or anomalies. For example, use intrusion detection solution to identify cyber attacks or abnormalities in network communications. Physical security is a fundamental aspect of OT security, focusing on safeguarding industrial facility and critical equipment. Some physical security measures include access control, limit physical access to sensitive areas using authentication systems such as badges, keys, or biometric recognition. For example, only authorized personnel should have access to production areas or control systems. Surveillance. Install security cameras and surveillance systems to continuously monitor sensitive areas. For example, use closed-circuit television cameras to record activity and identify potential threats. Environment control. Maintain optimal environmental parameters for critical equipment operation. For example, in power plants, ensure temperature and humidity in machine rooms are controlled to avoid damage to generator or turbines. Intrusion detection. Utilize intrusion detection sensors to monitor vulnerable areas and detect any unauthorized access. For example, motion sensor can alert if someone is attempting to enter a protected zone. Moving on next slide, let's explore cutting-edge technology to ensure operation technology security in our power plant. These technologies are crucial to protect control system and OT devices from cyber attacks. Industrial firewall acts as digital guardians, filtering and controlling network traffic in real time. Imagine using industrial firewall to protect data flow between control system and production network in our power plant. These devices block unauthorized access and prevent cyber attacks from external systems. Segmented networks dividing our power plant network into isolated subnets. Each segment contains only specific devices and systems that need to communicate with each other. In this way, we limit the propagation of potential attacks and protect critical systems from unauthorized intrusion. Virtual Private Network VPN. We also use VPNs to enable secure and encrypted communication between various power plant sites. These secure connections are crucial when transmitting sensitive information or remotely controlling systems. Even with the best security measures, we must be prepared to face incidents. This slide emphasizes the importance of a detailed incident response plan. Incident response plan. Imagine facing a cyber attack compromising our power plant's control systems. Our incident response plan guides us in timely response, containment of the attack, and restoration of operations. This plan is crucial to efficiently and effectively deal with the emergency situation. Business continuity planning is another crucial aspect to ensure our power plant can continue operating even during emergency. For example, imagine a BCP that identifies critical activities and fallback solution in case of damage to the main facilities. This planning is essential for our operational resilience. To ensure secure management of operation technology, we follow best practices and reference standards. In this slide, we consider the IEC 62443 standards globally recognized in the industry to ensure the security of industrial control systems. Imagine our power plants adopting these best practices, conducting regular security assessments, and updating protocols to stay aligned with current standards. This focus on security establishes a solid foundation of protection for our critical infrastructure. Our journey into the world of OT security is coming to an end. With the right technology, strategy, and incident response plans, we are ready to face the challenges and protect our power plant. Imagine a future where OT security acts as our protective shield, allowing industrial operating to thrive without interruption, ensuring reliable energy for the entire community. As we continue to grow and adapt to the new challenges of industrial Internet of Things, OT security remains the key to building a better and safer world. Thank you for joining me in this presentation on operation technology security in our power plant. With our dedication to security and innovation, we can confidently face the future and keep our critical infrastructure safe. OT security is a collective responsibility, and together we can ensure a safer environment for everyone. Thank you and have a great day.